3. This is a lesson on complex numbers. So complex numbers came up. They should have come up prior to enrolling in Algebra 2. You should have seen them before. At least the phrase complex numbers. I know that I mentioned it often um, as we worked on things. So I'm just gonna get started and just roll with it. So complex numbers. Complex numbers. Hold on, it's not working correctly. Let's try that again. There we go. There we go. Complex numbers are imaginary units. So, and they are denoted by the imaginary unit I. And they are usually represented as negative numbers. And these negative numbers are placed inside of, here I want you to highlight or underline the square root or an even root radical. So we would never see them be produced from, we typically keeping it to the level of college algebra and under. College algebra and under, you would never see these imaginary units come out of an odd root radical. So only these radicals with even roots would we be addressing complex numbers in high school math. So you would see them in the form of generally a plus bi, generally. And we don't really do a lot with the complex number form, this real part and this imaginary part. But the imaginary unit looks like this. And if I was using a variable, let's say I was using the square root of negative m, that's like saying the square root of m times I. And essentially what I want you to understand is this. The square root of a negative 1 equals I. Any number times that negative 1 is that number negative, and it produces the imaginary unit, I. So what does that mean, Ms. Smith? So what I typically do is I take apart what's inside, and I implore you to do the same as well. So inside of this radical is negative 25. I'm going to take this apart and set it up the way that works for me. So I have this equals also the square root of negative 1 times, actually we're going to put that number first. This equals the square root of 25, it becomes positive, times the square root of negative 1. And I'm not going to solve anything just yet. I want you to break these things apart. Inside equals the square root of 225 times the square root of negative 1. And we're just going to do those two. I want you to kind of put it all together with the third one. So after that process, I'm going to take the square root of 25 and I get plus or minus, don't forget, plus or minus 5. And the square root of negative 1 is I times I. You put these together, you get the answers plus 5i's, comma, minus 5i's. Okay? Now, next one, square root of 225 equals plus or minus 15. And the square root of negative 1 is I. So putting these together, my solutions are plus 15 i's and negative 15 i's. Okay? So keeping that in mind, let's do the next one. It's equals the square root of 169 times the square root of negative 1. That gives me 13 plus or minus times I. Putting that together, I get plus 13 imaginary number, comma, negative 13 imaginary number. Next one, I have Taking this apart, negative 2 times the square root of 36 times the square root of negative 1. So part by part, I have equals negative 2 times 6. And keep in mind there's a plus or minus there. Plus or minus there. Times I. Okay, how do I deal with this plus or minus? Well, you just get negative 12 i's, comma, 12 i's. Still a positive, still a negative. Okay, next one, we have a variable term in there. So if you don't recall how to do variable terms, we're going to do that. But first, let's take care of this number. 36 becomes positive. And I'm going to just write the square root of x to the 6th. And then in red, I'm going to have square root of negative 1. So this is obviously going to be I. Okay? If you don't recall how to get rid of the radical for even exponent numbers, you divide the exponent by 2. So we're going to do that here. Divide this exponent by 2, and we get x cubed. It comes out of the radical. Okay? Now square root of 36 is 6 times, don't forget there's a plus or minus out there, times 8. So I'm going to simplify. I get plus 48 x cubed I, comma, minus 48 x cubed I. Next one equals negative 4 times the square root of 100 times x to the 4th times negative 1. And simplifying, I get negative 4 times 10. Divide by 2 for the exponent, and I get times x squared times I. Putting it together, I get negative 40 x squared I, comma, positive 40 x squared I. All right? Now, how do imaginary units work? Well, in general, we know in order to get to I, in order to get the I, this equals the square root of negative 1. And there's a cycle. When we're setting the imaginary unit to a power, there are 4 possible results. Use a vicious, not a vicious cycle, a nice cycle, which makes it easier to do things and manipulate things with. So when I have I squared, that's like saying I times I. That's like saying the square root of negative 1 squared. Anything squared is just itself. So this equals negative 1. When I have I cubed, it's like saying I times I times I. And it's also like saying the square root of negative 1 cubed. Well, what happens to the square root of negative 1 cubed? You're going to get the return of negative I. Negative I. So how did you do that? Well, if you broke this apart, which I want you to see, if you broke this apart, you get I squared times I. And this is the same as saying negative 1 times I, which equals, in turn, negative I. So all I did was use the parts, and you're going to see that in the next, how we can break these apart, and we can return one of the basic results here. Square root of negative 1, negative I, or 1. Each time we set the imaginary unit to a power. So I to the 4th equals I times I times I times I, or it equals 1. So how does this occur? Well, I times I is I squared times I squared. If I look at my exponents, 2 plus 2 equals 4. That equals 4. This is like saying negative 1 times negative 1, or equaling 1. So that being said, If we continue to add these, put these numbers to a power, we can begin to see a pattern here. So I to the fifth is like you break it apart. I'm going to break it apart into I to the fourth and I, okay? With a remainder of I to the first power. I to the fourth equals 1 times I to the first power equals the square root of negative 1. So here, this results in the square root of negative 1. Now I to the sixth, I'm going to say I to the sixth. I'm going to break this apart. And I get I to the fourth, and I should have, in order to make this equal each other, I need 2 more i's squared. Okay? And simplifying this, I to the fourth equals 1 times negative 1, or negative 1. I to the seventh, breaking it apart, I get I to the fourth, I to the third. So I should have equals 1 times negative 1, or negative 1. I to the eighth equals I to the fourth times I to the fourth equals 1 times 1, or just 1. So if the exponent is, if the exponent is divisible by 4, it's going to equal 1. Your term is going to equal 1. Okay? So doing these problems here, I definitely like writing things out. So I write I to the fourth, I to the fifth here, and then I can break this down even further. I to the fourth, I to the fourth, and then 1 more I. And this equals 1 times square root of negative 1, or square root of negative 1. Here I have I to the fourth, I to the fourth, I to the 2. So 1 times negative 1 equals negative 1. Here I have I to the fourth, I to the fourth, I to the cube. So I have 1 times negative I equals negative I. Over here I have I to the 12th. This is divisible by 4. So it equals 1. It equals 1. I'll let you do these problems on your own. And things you should get the square root of negative 1, the negative 1, negative I, and the square root of, and 1. Okay? Now, the calculator can do this for you. So you would need to go to, you would need to find the imaginary key. So you need to change the mode to A plus BI, and it'll do it for you. So how do I do that? You go to mode, and we go down to real, and we want to change our format to complex numbers. Second mode. And now I can say, for instance, parentheses, second period to get that I. So second period, close my parentheses, up arrow, 47. Okay? And the problem with this is the return is something that looks weird. And what you're going to have to do is go to math, and we're going to go right arrow over to num and use number 3, I part. And we're going to try that again. And we're going to say second I, close parentheses, to the 47th power, close parentheses. And the return is negative I. Okay? So going through, you should be able to get the answers for these next 4. So following through those steps again, I to the 15th, I'm going to press second enter and just change my exponents to 15, and I get negative I. Negative I. I can predict, if I break this down into parts, this equals I to the 20th times I squared. Because 20 plus 2 is 22. So this equals 1, this equals negative 1. So you should be getting negative 1 back in your calculator. Here you should be getting negative I. Sorry, not negative I. You should be getting not negative I. You should be getting the square root of negative 1. Square root of negative 1. All right. But and here you should be getting 1. Okay. So going to my calculator for I to the 13th, I believe. Let's make sure of that. Nope, I to the 22nd and then I to the 13th. So math, right arrow over to I part 3. And I have second I to the 22nd. Enter. And I get negative 1. Math, right arrow over to I part 3. Second period, I to the 13th. And I get I. I get I. So we don't write the radical negative 1. We should be writing I, right? Should simply be writing equals I here, okay? Last one is divisible by 4, the exponent is, and it just equals 1. So things I keep in mind, I'm going to pull out my negative, so pull out the negative, and if necessary, otherwise, simplify first. Okay, so let's do that. So we have, just simplifying inside, I have the square root of positive 36. I don't have to get an imaginary number back because this just equals plus or minus 6. So my answer is plus 6, comma minus 6. And use curly brackets. Okay, over here I have equals. Separating this, I get square root of 4 times the square root of negative 1. Okay, and then I get times square root of 6 times the square root of negative 1. And I have square root of 9. So negative 1 times square root of 9 times that. I get 2i times 3i. That's going to give me plus or minus 6 times a negative 1. This equals, doesn't matter if it's negative, it's still going to equal negative 6, comma, positive 6. Okay? Next one, if I wanted to, I could rewrite this and say negative 6 times negative 6. This equals the square root of 36. Take the radical of 36 and I get plus or minus 6, or in other words, curly bracket, 6, comma, negative 6. Either way, there's a couple different ways you could have approached the problem, is what I'm saying, or what I was trying to show you or attempt to show you, okay? Now, the next part, square root of 10 times the square root of 60, square root of 6, negative 6, square root of negative 10 times square root of negative 6. This equals positive 60. And then we're just going to break down the radical in the parts. 2 times 30 equals 60. 2 times 15 equals 30. And 3 times 5 equals 15. So when I set this up, this equals 2 comes out of the radical, 1 goes away, but inside remains 15. Okay? So the answer here is plus or minus 2 square root of 15. Here, I like to simplify before I do anything else. I like to do this. 18 over 9. It's both of them negative, produces a positive, equals the square root of 2. Okay? So, equals plus or minus the square root of 2. Plus or minus, plus square root of 2, minus square root of 2. And that's all she wrote. For this following one, we have, I'm just going to take the whole radical of negative 48 divided by 24. This equals the whole radical of negative 2. I want to get this, simplify this. So it's 2, square root of 2 times square root of negative 1. This equals plus or minus square root of 2. I. And how do I write that? Square root of 2 times I, comma, square root of 2, negative square root of 2 times I. Okay? Now, when we're combining like terms for imaginary numbers, I like to highlight my number terms and rewrite them. And then I like to highlight my variable terms and rewrite those. Okay? So I'm not going to do, well, actually, I'm going to do all these. So, number terms, all highlighted. Imaginary parts, highlighted, and ready. Okay? So, putting those together, I have 3 minus 5. This plus distributes to a negative 5. Plus, let's just say plus, negative 4i's plus 7i's. Okay? Combining like terms, I get negative 2 plus 3i's. Here's my final answer. Okay? Over here, negative 6 minus 8 plus 4i's minus 9i's. Is that correct? No. You made a mistake. I made a mistake. We need to be careful. In between, you need to change the signs. Because a negative and a negative is positive 8. Plus another negative and a negative is positive 9i's. So I have negative 6 plus 8 plus 4i's plus 9i's. Gives me 2 plus 13i's. Okay. Last one, negative 2 plus 3 plus 5i's plus 7i's, or 7 imaginary units. And I get 1 equals 1 plus 12i's. What about when I have to distribute twice? Well, put your numbers together. So 5 times 3, and then I times I, that's 15i squared. You do need to simplify. This equals negative 15, and here's my final answer. Over here, we're distributing to all of this, distributing 3 to all of this, so I rewrite it. 3 times the quantity of negative 5 plus 7i's. And then second part, negative 4i's times negative 5 plus 7i's. And I have negative 15 plus 21i's minus 20, or plus 20i's minus 28i's. I squared, 28i squared. Okay, simplifying, I have negative 15 plus 41i's minus, so plus 28, because I squared is a negative number, and then I have another term to combine, and that's 15 and 28, and I get 13 plus 41i's. Final answer. Okay, and here I have negative 4 distributes to negative 12 plus 3i's, and then positive 8i's distributes to negative 12 plus 3i's as well. Okay, now How do I simplify this? You distribute. So the first part I get positive 48 minus 12 i's minus 16 I, oh sorry, 16. 8 times 12 is a 96 i's. And then 8i times 24 i's. 3 i's is positive. It's positive 24 I squared. Okay? So you have 48 coming down. These combine to give me 108 i's. And over here I get negative 24. Okay? Combining, I get 24 minus 108 i's. Now, complex properties, field properties, there's distribution, where we have a number times two other numbers. And we distribute by saying 2 times x and plus 6, just simplify. There's also addition, subtraction, where you're subtracting on both sides. There's division, where you're dividing on both sides. And there's the identity problem. Identity property, where you're just adding a number to 0 and producing that number. The inverse, on the other hand, you're getting rid of a number. You might say a minus a equals 0. That's for addition anyways. Identity for multiplication is a times a number equaling itself. Inverse for a for multiplication is a divided by a equals 1. Okay, so we're going to be looking at properties. So identify the properties represented below. Here I have this equals, when you produce 1, you're either getting the inverse or the identity. So typically it's the inverse, so you're multiplying by a reciprocal here. So this is the inverse property of complex numbers. Next one, I think I skipped over the associative property, where they change the order of things. So what did they change? They flipped over these two things. And it's not associative, it's commutative. Next one is a transitive property. Just those if-then statements. Third one is distributive. Fourth one is distributive, And E is commutative. And I'm going to go ahead and just describe the changes that I see. So from step 1 to step 2, looks like they're producing 1 here. And what they've done is use the property of inverses. Okay? You go to the next step. What do they do? They put it together. The last step, they have they simplified that a bit. So from step 4 to step 5, what do? They said 1 times r equals r. So this is the identity property. R retains its identity, and an identity property of multiplication. Because any number times 1 equals itself. All right, guys. So for your homework, you have homework number 3, actually number 2, and it's complex numbers. Go back and you look at the video, look at other videos for resources on how to perform these tasks, And I hope you have a very nice day.